Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Sao Paulo in Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenters to answer. I will now turn it over to our speakers for today. So let's welcome here Chris and Wasim.
Hey folks, I'm Chris Noring. I got Wasim Chegan with me. We're super excited and stoked to bring you MCPs actually on Azure, right? Because all of you, you've seen MCP features so far, but you might be wondering, how do I actually deploy that thing? And I think, Wasim, you have a great answer for us, right?
Yeah, thanks, Chris. Hi, I'm Wasim. Yeah, and hopefully today we're going to show you how to build your streamable HTTP MCP and also deploy to Azure. Are you ready?
Heard the man. You heard the man. So yeah, very, very excited because it feels like it's becoming more real, right? So we'll definitely cover topics around deployment. We'll talk about authorization, authentication, and some good architecture practices to make this thing viable. So with that said, let me share my screen and we'll kick things off. Right, so in today's episode of MCP Bootcamp, we'll talk about how to build and deploy your MCP server on Azure. Let me see here. Here's the two of us. Here's me. I'm Chris. Wasim, you already said a few words. So if you're interested in connecting with us, we're here with you on LinkedIn as well. So happy to take any comments or questions. Right, so this is the table of content for today. This is our agenda. We have a three-part act for you. First off, we'll present what this app is, what it does, what the architecture is like, also how you can set up some good authentication mechanisms that will set you up for success. And then, of course, we'll show you a little demo of a running app so you get a sense of what we're going to build with you. In Act 2, we'll talk about how to prepare for deployment, meaning how do we even choose this, a hosting service? I mean, on Azure, there's so many choices, right? And then do we need to containerize? Maybe. Bicep, I think you're going to talk about Bicep, right, Wasim?
Little bit. Yeah.
Little bit. Yes, and in our final act, we'll talk about the deployment and some beyond. And when it comes to beyond, you'll hear from me a bit about what to think about, because now we hope that you have actually integrated some kind of LLM on the client side of your MCP app. So there's also some things to think about that, but there's also some useful services on Azure that will help you build MCP servers in minutes. That sounds exciting, hopefully. Right. So let's take you all to the app itself, a to-do app. Like, I know you haven't seen to-do apps before, right? Completely novel, new, never seen it. I don't know what you're talking about, Chris. But yes, humor us. To-do apps is the hello world of 2025, I think. In this app, you can list to-dos, you can add to-dos, remove to-dos, complete to-dos, and even use tools like Visual Studio Code to consume it, and what's known as the inspector to run your features and make sure that they behave. With that said, I'm going to leave it over to you, Wasim, so you can demo the app and see how that works out.
Sure. Yeah, maybe we can switch to my screen. And yeah, something we didn't mention, actually, it's not a simple to-do app. It's an MCP server, actually, running as a to-do app. So as you can see here from my screen, I'm using here the inspector. I mean, we can go probably dive deep into the code later on, but this is the end result. And actually, it's a server running behind the scenes. I can share with you my VS Code. As you can see here, I have my application server running, like the MCP server, the actual MCP server. And I also generated some tokens for the demo. And I have the, like the official MCP inspector app running, which is the one you're seeing here in my screen. And it's connecting to the actual MCP server running locally on my machine with some job token for demonstration purposes. So obviously, yeah, I can list all the tools that are exposed by this server, by this MCP server. And as Chris mentions, it's a basic to-do. So I can list all of it, my items. And as you can see, I already have one here, which is run the demo, which I ran actually earlier. I can add another one, foobar, and then call the MCP server that actually insert a new item in my in-memory database that I'm using here for the demo. So that's the actual application we're going to demonstrate today and show you how to build it and also how to deploy it to Azure.
Great.
Yeah, back
Thank
to
you
you,
so
Chris.
much, Wasim. Yeah, thank you, Wasim. So what's super interesting about the inspector tool is that you not only use it for localhost, right? But you can also use it on Azure
Yeah.
once you've deployed. So all you need is an endpoint and a token, right?
Exactly, yeah.
Yeah, let me continue our little conversation we have here. So switching back to me. Right, so this is a mile-high level of the MCP app, because I bet you're wondering, what are all these moving parts? Wasim, you mentioned that there's a server involved, but if we begin with everything from the left, if we read this from the left, we start with the user interaction, we can see how the user is going to end up talking to a client TS file. So, for example, they want to list to-dos, but for those to-dos to be rendered back to you as a user, it needs to go through a few hoops, right? So there are middlewares that needs to be checked: jot token, helmet configuration, JSON middleware, URL encoding middleware, and of course, timeout middleware and rate limit, because we want to have that as we move into production, right? We don't want abuse of our API endpoints. And of course, if we go through the scenario, if it survives all the hoops going through all the middlewares, then we end up calling the server, right? So at this point, we're calling the server, but now we need to check that this is actually an authenticated user. And if it is authenticated, then we need to check that this user has permission to run the tool that we're asking for. So we have some clever setup that I'll show you in a little bit. But what happens at this point, so providing everything checks out, that you are logged in, that you have access to run this tool, then you will get a JSON RPC response back to the client, and the client can now send this to-dos list back to the user. And if we unfortunately encounter any of the scenarios where we weren't authenticated or we didn't have permission to run this tool, we end up getting some kind of error response and 400 codes back. So this is the mile-high flow, I would say, of the app. So if you understand what's going on here from the normal flows to the alternate flows, you understand the app pretty much. Anything you want to add on top of this, Wasim?
I mean, yeah, if folks want to follow along, we have included the link at the bottom there, so they can actually check the code and the repo, even like running locally if they want to.
Super. Yeah, okay. So here we need to talk about auth, right? And usually when we say auth, we mean two different concepts. We mean authentication, having you logged in, and authorization. How can we ensure that you have access to the right resources at the right time? So these are two concerns that we kind of need to address. And so what we're about to show you are some mechanisms that you could be adding to your application. And what we're saying is at least have these, and then you can always harden security as you go along, as you are deploying this on the cloud. So what we're going to start with is authentication. How can we make sure that you are a user that should have access to the system in the first place? Well, there is a subdirectory inside of the solution, an auth subdirectory with a jot.ts file. Within there is a function. And in that function, it checks, first of all, that your request has a bearer token. If it doesn't have a bearer token, it's like, go away. But if you do send a token as part of your request, then we start checking whether this token of yours is valid. So we have a nice little JOT service that can validate the token. And once we're able to get the token back, then we can get a user back and we can assign that user to your incoming request. So then we downstream can validate whether this property is set or not. So that's how we kind of set things up for ourselves. With the other part, authorization, this is about having access to the right resources, right? So the very first thing is that we are trying to create a user so that you can use the app in the first place. for the sake of demo purposes, we have set up an admin user that can do everything. But the way we've set up the system is to make it possible for you to test this with different access level. So we do recommend that you create different users so you can test that all of these authorization levels have access to what they should have access to. But starting with a demo user, we see that it's an admin, right? And we see that they therefore has a user role.admin. But for us to set up the entire authorization system, we need roles. So we define the roles admin, we define a role called user, and a role called read-only. And then we need to set up permissions. So imagine now that we have different CRUD permissions. So create, read, update, delete. All of these are permissions that we want to be able to assign. And then we need to be creating a mapping between roles and permissions. So here you can see exactly what each role then have access to. So if we were a demo user here with that subtype admin, then we can read to-dos, we can create to-dos, update to-dos, delete to-dos, list to-dos, call tools. So pretty much everything. However, if we are a lower level user, namely a normal user, we can do almost everything. We can read, create, update, list, and call tools, but we can't delete to do. So here you can see that there's a slight difference between the two roles. And if we are a read-only role, we can read to-dos and list tools, which makes perfect sense. We shouldn't be able to do more if we're called read-only. And lastly, we have a tool and permission mapping. So this is a mapping that we're going to be using as part of the application to make sure that a certain tool has access to a certain permission level. So here we are kind of intermixing a tool with the permission level. So we can see, for example, that if my tool is called add to do, that is the same thing as the permission level create to dos. If I'm doing list to dos, then that is the permission read to dos, and so on. So now we have really set things up for us, and you see how flexible this is. So if we want to create more users, we can do so. If we want to have more role permission mappings, we can do so as well. If you feel like there's a middle ground, for example, between user role and admin. Now, question is then, how do we actually validate all of this? Well, imagine now that we come in here and we try to check what permission level we have. So the first thing we're going to do is to bring in a tool name. So the tool name is the input into this function. So now we're checking the tool name. And if we don't know which tool this is, then we're in trouble, because then that means that the calling client is trying to ask for a tool that we don't even have. So this is just end game, the first thing that should happen. However, there is once we pass that check, then we go into a check that says has required permission. So now we're checking then if the user can actually have permission to do this. So if we're an admin, we will have access, right? But if we are a normal user, we might not have access if we are, for example, trying to delete something. So this is where we do that check to make sure that whatever we're trying to do, we are the right user with the right permission to do the right thing. And here is where we actually come into the MCP server itself. So if you've seen a few past episodes, you will have seen that there are two ways of building an MCP server. One of them is by creating a tool. For every tool, we do our own creation and our own callback. But if you use a lower level server, we're going to use something called set request handler. This enables us to have complete control of listing tools and calling tools. And I would even argue that it's easier to set up an architecture when you use set request handler. So within this handler, in which and this handler has a schema. The schema is called the call tool request schema, which means every single attempt to call any tool will be handled by this function. So what we're doing in here is first check if the user property, if you remember earlier, if the user property is not set on the request, then we're in trouble, right? So if we don't have a user, then it's an unauthenticated user trying to do something. It's endgame completely here. We're just saying, no, go away. You can't do this. However, there might also be another case here in which the tool itself that you're asking for doesn't exist. So this could happen. There could be a mismatch on the client or user side where they're trying to ask for a tool. There's also a phenomenon with MCP servers that they can be quite dynamic. You can add more tools as you go along, but this is clearly a mismatch, right? If we see that the client is trying to ask for a tool that doesn't exist. Now, here's where our authorization really shines through. So here we're trying to get the permissions then by tool name, and we're trying to check whether this user has this permission level. And everything checks out here. If it's all good, then we are actually allowed to do whatever we need to do for the rest of the time. However, if the user, for example, a normal user here tries to delete something and they don't have the permission level, then we should return back a JSON RPC error message. So this is going to show up in the client SDK as an error, and we need to give an appropriate response back to the end user to say, sorry, you didn't have permission to do whatever you're trying to do. But of course, if you design your app well, hopefully this should never happen. Like, for example, if there's a delete button, it should either not be visible or maybe it should be disabled. So hopefully the end user will never see one of these errors, but we still need to build code for it, because at the end of the day, we might not know what kind of client are calling us. We just need to make sure that the fortress that is our app is made secure for unauthenticated or unauthorized access. Anything you want to add on all of this, Wasim? Anything top of mind?
You're doing good. Keep going.
Awesome. Thank you. He's drinking his coffee, I think. Right. So as you can see, all of these mechanisms are key to have in place already, right? Authentication mechanisms, authorization mechanism. We have laid a very nice foundation for you that you can build upon. You can add more users. What we can do, though, to harden things further is using what's known as an IDP, or identity provider. For example, on Azure, that's called Entra ID. So we can definitely take this a step further by, and Wasim was saying this earlier, he's generating tokens currently. But if we integrate this with Entra, Entra would be the party that actually generates and validates the token. So this is something we can outsource to an IDP. But of course, if you're not completely bought into Azure, we hope you are. But if you're not, there's a lot of other identity providers in other clouds. And there's even something called Okta if you're using some third party. Completely up to you, of course, but we have everything on Azure. That's one thing we pride ourselves for, that you can do everything you want to do on Azure. So definitely check out Entra if you're looking to harden this solution further. Now, I just wanted to mention also in MCP, in the MCP SDKs, we are supporting OAuth 2.1. So what does that mean? Well, there is a middleware that you can actually jack into in the MCP SDK. And actually, so what you're doing at that point is to point out an authorization server that you want to send people to. So that could be your Entra server, for example. It also points out the resource server, which is your MCP server. And the middleware takes care of a lot of things. But what you need to do, though, is to submit some kind of permission level. And if I remember correctly, that permission level is going to be the same on all the different tools. So I think there's still some legwork to be done in MCP SDKs to make it as flexible as the solution that we have created for you today. But the point is, there is some support. So if you want to go 100% bought into MCP SDKs, OAuth 2.1 is supported with code flow. So if you don't know what that means, mile high level, that means that the first time you do anything, you call an authorized endpoint, which could be Entra or whatever IDP you're using, and back you should be led into a login page. So once you log in, you should be receiving a code, and then you can exchange that code for an actual bearer token. Once you get that bearer token, that's what you're going to use to be calling this MCP server, and then it should hopefully say, happy days, here are your tools, or here is the end result of calling a tool. So now you know that we have some nice mechanisms in place. You can definitely harden the solution, and there you can also check out the built-in support in MCP SDK that helps you some of the way with this. Now, I believe we might have a demo here, right, Wasim?
Yeah, sure. I can go through the code and also run the demo to really highlight what you said earlier. So something I also want to make it clear, actually, for everyone is that when we built this demo app, actually, we built it like quite a few months ago when the MCP specification for authorization were still in flow, like they weren't stable yet. So this is why the authentication mechanism that we baked into the solution is based on GWT standard and not actually the full MCP spec compliant yet. That's something we will be including in the future, so stay tuned. And also, just make sure to start the repo so that you get notified with future changes. So for now, and I'm not going to show you what Chris already showed in the slides, but basically that's the same code that you will find in the repo, in the project. But what we have in place is this token that we actually generate locally. This is for convenient because we didn't want to like bother you with setting up an ID like an authorization server or a provider. That's something up to you. You choose which provider you like to work with. But for this demo, we have a convenience script that we run actually to generate a token that we then can use. And that token actually hold some user details like their role, which is important for us. So we have multiple roles, as Chris mentioned. And now I'm going to show you how these authorization actually work. So I already generated a token for an admin, as you could see from here. And the token lasts 6 hours because I didn't want to generate multiple tokens for the demo. But you can customize this the expiry date. So now if I go back to my inspector application, I'm actually authenticated with the server using the admin token that I just showed you earlier, which is obfuscated here, obviously. So because I'm an admin, when I request the list of tools, I get actually all the tools, even the delete one, and the tools that actually change the data. Obviously, yeah, I'm not going to demo them for you because we already showed you that earlier. What I'm going to highlight instead is I'm going to generate a new token with a different role. So for that, I'm going to run npm run, maybe you can zoom in a bit, generate token, but this time I'm going to use the read-only profile. So again, this is generating a new token for me, but with the read-only profile. Now I'm going to copy this token, go back to my inspector app, and then reconnect with the new token. Okay, not working, obviously, because I need to restart my server so that my server is actually, so it can use, the new token. Oh, sorry. Now I need to copy back this one and make sure I run the server, and I go back to the inspector, use the new token. Now I'm logged in. I'm authenticated with the read-only profile. Not really. Let me.
Did it rebuild the server, or did you just restart it?
Just restarted, actually. So yeah, I'm connected with the read-only token.
There we go.
So if I list back the tools, I can only see the list tools because I can only read the items in my database.
This is actually a very good practice to hide the tools that they shouldn't have, so they can't hurt themselves, right?
We recommend using like a fine-grained authorization mechanism. Obviously, I have another role, which is user, which is not an admin. So I think this user cannot delete any tool, any entry. Rerun the server, go back to my inspector, copy the new token, reconnect back, clear, list the tools. And as you can see, I don't have the delete tool, so I cannot remove things from my database. So that's how the authorization mechanism work. And yeah, for the authentication, as Chris mentioned in the slides, we are basically using the really standard GWT authentication system. Nothing complex about this. And yeah, hopefully in the future, and we will do this actually, we want to really comply with the standard, with the MCP authorization standard. So stay tuned. We will be implementing this soonish. And I think now the next step, Chris, do you want to talk about preparing the app for deployment, or also?
Yeah.
I forgot to ask, by the way, if folks have any question, maybe we can just show them on the screen while we go through the app. Or otherwise, yeah, we can maybe just go to the next step. What do you think?
Okay, great. I think that sounds good. But yeah, if there's any questions, please bring those on screen or Yes. Okay, let me keep presenting. So
Yeah,
give
back
me
to you,
a
Christoph.
sec. And back to my screen. Okay, so we need to prepare for deployment, right? I mean, everything looks good. We got the local app. We can generate tokens, as Wasim was showing you. You can have different authorization levels, and we even filter what tools are available. Because if we didn't, the user might be tempted to run a tool they don't have access to, and they see an error, and that's not a great user experience. Right. Okay, so as we are preparing for deployment, we need to think about deployment as like, okay, it needs to end up on Azure, right? We know that much. We have choices though, because there's more than one transport to support that. So transports are answering the questions of where will my MCP server run? If you're completely new to MCP servers, you might have built a few servers already with standard IO. That's fine if the MCP server is running locally on your machine. But as you want to be able to consume it from a URL, you need something else. So there's SSE and there's also streamable HTTP. However, SSE has been deprecated, I believe, since May. So if you have built SSE servers, consider migrating those to streamable HTTP. And I believe, Wasim, this is built on streamable HTTP. So it's nice and latest and greatest. And secrets management, of course, we should never have any secrets in code, right? So if you got any secrets in code, bring those out of there, have those in env files, or rather not at all. So you want to make sure that you do this check, right? Some hygiene check of your code, make sure that there's nothing in there that you worry about. So in theory, if you check in your code in a public GitHub, you should be fine, right? So that's how you kind of know that you're fine. If you're not fine doing that, you probably have some things in your code that you need to take away. Now, depending on how we end up deploying this, we may need to containerize the app, meaning that we need to prepare it to run in any environment, right? So Docker is a very popular technology for containerizing things. There's also Containerd and a few other services. So choose what works for you. There might also be some other configuration in your app that you might be interested in setting up. What that is probably up to you and your business case. We don't know everything. We're just giving you a reminder that, hey, now is the time to think about config. Now, because we're also thinking about deployment, and for deployments to be repeatable, we need to talk about Bicep scripts. Bicep scripts are how you describe your cloud resources and how those should interact. And because once you feed a Bicep script into the engine on Azure Resource Management, it should then recreate and or update your cloud resources so that your app has somewhere to be. And then, as we talked about earlier, we have a great start when it comes to setting up auth, but if we want to choose an identity provider, now is the time. If we do that on Azure, that's probably Entra ID, by the way. So, and then, of course, because it's Azure, we have so many Lego blocks for you. There is, of course, more than one service that could be used for this. And we will try to explain why we went with a specific one today, or you'll hear more from Wasim around that. So here is architecture for deployment, very mile-high view. As you can see, we start from the top with the user, and the user talks to some kind of hosting environment, which could be a web app that you built, or it could be Visual Studio Code if you consume it from there, or, for example, from the inspector. That's also considered a hosting environment. The point is that from this hosting environment, you are initiating connections with the client, and then the client end up talking to a server, your MCP server, with its features in there. And this display also here on the top left is showing you that your client should have access to an LLM, because that makes for a better user interaction. So instead of the user explicitly calling a tool, a resource, or a prompt, the user instead prompts, and you have an LLM on the client and then interprets what that means. But for the sake of that LLM, that could live in many places, right? That could be OpenAI, that could be a free AI, like from GitHub Models, or you could have deployed an AI deployment on Azure AI Foundry. So it's a little bit up to you. We're just mentioning that the MCP client should have access to an LLM because of that better user experience of naturally be able to choose a tool without knowing that there is any tools if we are a user. Now, looking at this, we see here that we then move on to the bottom half of this diagram where we have an MCP HTTP server that sits on a number of tools. All of these tools are around things to do. So completing it, listing it, deleting it, adding it, and so on. And we also have the notion of a data storage. So moving the data storage to the cloud to lift and shift, that's also something we need to consider. And we have many, many different options out there. If we want a regular SQL database or we need a NoSQL, depending on how we built this, we could in theory be using, for example, Cosmos DB with NoSQL or maybe the SQL accent. We could be using Postgres and so on and so forth. So depending, we don't really know what the right answer here is for you. We're just saying consider what your data source is in the cloud. It could be many, many different options. Right. So when it comes to containerization, do you want to have a go here, Wasim, to explain to people what you've set up?
I mean, there is nothing particular about the Docker file actually, and that's really not going to be specific to our app. So this one is really specific to our Node.js Express application. Just make sure it's production ready, because we sometimes can have Docker files that are supporting us in dev mode, and other ones need to be configured and secured for production. So we're not going to spend a lot of time about each line of Docker in this Docker file, but yeah, just use any existing or standard. Maybe your company has a standard Docker file for your applications, or you can find tons out there on the internet. Excuse me.
Great. So per what Wasim was saying, he said there's nothing special about this Docker file, but just know that you might pull in the right image, for example, if you are pulling that from some kind of Docker hub, or maybe you're using some kind of container. Help me here, Wasim. What do you call it? A container registry on Azure,
Yes,
right? So, right. So moving on. So now we're thinking, okay, we have so many different options, right? So for example, Azure Functions support creating MCP servers. Azure App Service can definitely host it. Azure Container Apps can do it. So maybe you can say a few more words. Why Azure Container Apps, you think?
Well, first of all, because I'm biased, but because I love containers. I love working with containers. But yeah, jokes aside, actually, Azure Container Apps are a fully managed. I mean, if you have your app which is already containerized and you're already using containers, so Azure Container Apps is Microsoft's offering, which is a fully managed serverless container platform, actually, that helps you simplify the deployment and operations of any containerized application. And what's great about ACA, Azure Container Apps, ACA for short, is that we also support serverless GPUs for your AI or agentic applications, so that you can bring your own containers and deploy them on a GPU-backed environment that automatically scale on demand. So yeah, really to simplify, some of the key benefits are auto scaling, so you can scale to 0 when idle, and also scale out with usage. Pay per second billing, that's really important. So pay only when the compute you use. And then also, no infrastructure management. You really focus on your model and your app. However, if you really want to have more control about your infra, then Kubernetes is another option, but we're not a Kubernetes configuration. That's really complex for us, for this scenario at least. So we'll keep it simple with container app with ACA. And it's also enterprise grade, feature ready. So out of the box, you have support for bringing your own virtual network if you want to secure your apps and your environments. We have also managed identity support, private endpoints. I mean, yeah, like the full data governance and the features go on and on. I'm gonna just stop here because I told you I'm biased, but yeah, and for me at least, I think container apps and containers in general is really the great spot, for building MCP servers. Because you can like, run them locally for testing, and then when you're ready, just deploy them to the cloud in a few commands.
All right. Yeah, wise words here from Wasim, like containerizing your app. That we've been doing that for at least I think the last 5 years or maybe more. Fantastic way, right? Because containers run the same on your local machine as they would do in the cloud, hopefully, because you can specify exactly what's in that environment, right? Exactly what libraries, what runtimes, what environment variables, and so on. So predictability is something you want, and of course, as you move to the cloud, you definitely want a platform that's not going to cause you a lot of pain because you need to remember all the details. If you are a Kubernetes ninja, we got Azure Container Service for you. If you don't feel like you are ninja when it comes to orchestrating containers, I think Azure Container Apps is probably a very nice middle ground. And as Wasim saying, you are paying for your usage, so make sure that you set that up. And the serverless platform generally grows with your business, right? So the more customers you have, the more usage. So hopefully that means you got money in. So you pay us a little fraction, and you can see that your business scales up, hopefully to millions of people. Now, when it comes to writing Bicep scripts, if you never heard of Biceps before, this is one of two dialects supported when it comes to the Azure Resource Management or ARM engine on Azure. That means that you can specify your cloud resources in text files. You can send that into our engine, and we end up updating or creating cloud resources. ARM is one dialect, Bicep is the other. So if you've seen something before like this, like Terraform, it's very close actually visually. So if you squint, you probably see Terraform. So my point is here with Bicep is that this is a great way to organize your cloud resources. And what you should know if you're completely new to it is that you have an entry point file called main Bicep. From that entry point file, we can then specify a number of modules that we want to deploy as part of that entry file. And we can completely organize our cloud resources in the same fashion that we are organizing our code. It's nice and neat, and everything has its own place. But when it comes to Azure Container Apps, there are a few concepts that you kind of need to know more about, like Azure Monitor, container registry, where we put our containers, as Wasim was saying, container apps environment, and also for the sake of, we are going to use a managed identity here, so a user-assigned identity, and a container image and a container app. That's pretty much all the concepts you need. But lucky for you, we've already done the heavy lifting by creating these Bicep files for you. So this is an example for you all to follow. We have set up an infra app or infra directory with all the Bicep files in it. But I believe Wasim will take us through that and explain exactly what you have in what file, right?
Sure, yeah, we can switch to my screen. So as Chris mentioned, we already, like in the sample, GitHub repo sample that we are using, there is a folder actually that's called infra, and that's the infra folder. It's a standard naming across all of our samples we offer on GitHub. And so to be honest with you, this folder and some of the Bicep code that's inside were auto-generated with our tool that we use, which is called AZD, Azure Developer CLI, which actually you can use. It's not just for us. It's for everyone who wants to deploy and bootstrap the infra, the Azure infra easily. So that's what we did, actually. We started with the AZD command, but you can write it by hand if you want to. But we actually use the AZD init command to bootstrap this Bicep code. And yeah, as Chris mentioned earlier, our main entry file is main Bicep, which basically define the entry point for our infrastructure, basically abstract away all the complexity of the rest of the infra. But the actual implementation details happen under the resources.bicep file. And that file actually defines the monitoring of your app if you're using monitoring, and we recommend you using monitoring with application insight. It also defines the container registry, some of the components that are necessary to run in your container with Azure Container Apps, the registry, the environment, the managed identity for security, and also the images and your actual application. So we're not going to really go into detail with for each, like each piece and each module, because this is really specific to container apps, and we don't want to bother you with this. But if you are curious, again, this is all available in the repo. The actual important piece here is the application inside. So Azure Container Apps, we have apps in the name. So this is what's important for us, application developers. And yeah, and the rest of the Bicep code could be handled by your cloud engineer in your company. But for us, we're really interested in the application itself. And in our case, and this is again specific to our app, in our case, our application needs some environment variables to run. Obviously, all the JIT token, the payload, everything. It also need some basic configuration, and this can be easily done through the Bicep AVM modules that we're using to simplify things. So we have the secrets. So that's all the secrets we're using. The GW tokens are stored in a key vault instance, and then we are just referencing actually those secrets here in our configuration using the secret property. And then we are passing all the values to the container. So these values actually can be fetched from different areas using thanks to the AZD. So it could be passed by us at the user while deploying the app could be passed through the environment variables, or stored in, or passed through the what we call the parameters, which are defined here. So in our case, for this application, we have set up a custom hook, and that's actually a script. Basically, the script that runs before or after each operation, before a deployment, before a provisioning, for instance. And in our case, we ran our command, like the npm run generate token command that we showed earlier, which is going actually to generate a .env file. And that .env file, we take it and then we copy it to the specific folder under Azure.env. I'm okay showing you all the secrets because they're all fake, and we're going to remove them after the the presentation. But that's important for the rest of the presentation. And basically, in the Azure YAML file, which is the configuration file for AZD, it's going to read this hook and then basically execute the command before we provision our infrastructure. And then because we have all the environment variables up and ready, they're going to be copied actually to the container and then deployed on Azure and provisioned on Azure. And then once the deployment has finished, so we have a post-provision script or hook that's going to basically just copy all the values that got created after we provisioned our infrastructure, take them and then copy them into a root file called .env as well, which contains the important information for my app to run locally, so that we have the same environment variables locally and also remotely on Azure. Please, Chris, tell me if I forgot anything, but basically I wanted to keep it simple for folks because this is not a talk about Bicep, about infrastructure. But basically, with Bicep, with a tool like AZD, but also other tools like the AZCLI, it's really easy for us, even us non-infra engineers, to deploy our containers to container apps, Azure Container Apps. And I'm gonna stop talking here.
I'm not sure. Did you mention the Azure verified modules or?
Yeah, I say the AVM, but that's actually Azure Verified Modules. And that's something you could probably spot here in my resources file. These basically are these modules that we have here. And there how would you explain this, Chris? Like simply, what are AVMs?
Uh, so this is just me, and you may correct me, but I'm thinking to myself that this is code I don't need to write, right? Because normally with
Yes.
Bicep, you have to write 100% of these are the resources I need. But what all you do here is to refer to a module out there and saying, use this Lego block. And this Lego block is also validated. So the product teams and dedicated people on Microsoft are actually ensuring that this module is going to
Yes.
work for you. So this is a great way of using a component that works really well, and you don't have to write the Bicep for it. All you need to do, it's almost like an include in the library, right? You're saying, I'm going to import this work done by someone else, and I can make sure that this works, and I don't need to write it. It's almost like a library. Am I right?
Exactly. Yeah, like blueprints actually that were verified by us, and that include actually all the security best practices and some default configuration. So this is here in this situation, for instance, in this case here, I'm calling the container app AVM, the verified module, and I just need to pass in these extra parameters. But if I click on this one, this is actually the inner implementation of the module. And as you can see, it's like 700 lines of configuration for Azure. And I don't have to write or need, probably not understand all of it. I just care about my environment variables, my replicas for my container apps, the ingress port, for instance. That's what is specific to my app. All the rest has been already done through the AVMs. Yeah, that's all what it is actually.
Great. So
Oh,
and now you not only see how you are creating cloud resources using Bicep, but you also see some best practices in using blocks, AVM blocks that's already created for you. All you have to do is add a reference to them and send in the output to make sure that they work as properly. So a little bit like a library, but most of all, it's Bicep code that you don't need to write. So now we know everything about Bicep and deploying things, or you could just do AC up, I believe, from this repo, and you should see a working deployment thanks to all the instructions that Wasim was showing you. But point is, we are giving you an entire app that's shippable. So you can just study the solution in your own time and try to break it or add to it or improve it somehow. So
yeah.
so now we see everything about the Bicep setup. So hopefully we're more familiar to what is Bicep, how can Bicep help me create and update those cloud resources on the internet, and how can I even use best practice Bicep by leveraging these AVM modules that lives somewhere else that's already created, and all I need to do is import them and refer to them. So now we'll talk a bit more about the deployment and what lies beyond, because right now we are showing you how to get to Azure. We're not necessarily showing you every single feature out there on Azure that you could be using. So Wasim has been talking about ACD, I believe, already, but let's rehash it a little bit. ACD is one of two deployment tools that you can use in your terminal to deploy cloud resources. The other one is ACCLI that you might be more accustomed to. The idea with Azure Developer CLI, why it exists, is because it wants to deploy entire solutions, which means a front end, a back end, and a storage. So we actually have a lot of recipes for ACD that you could be using to deploy what you need. For example, a Postgres app with a front end and a back end, front end being React and the back end being .NET, for example. Now, the commands you need to remember when it comes to ACD, there's not a lot of them. ACD in it is how you scaffold the new project. So you have that Azure YAML file. So what you could be seeing that like Wasim was doing earlier, these are the steps I want. These are the pre-steps. This is the main part, and this is the post steps. All of that is encoded within that project file of yours. And then, of course, you run ACD up, and then it starts deploying. And the beautiful part of all of this is that you can easily do a change to your cloud resources and hit ACD up again, and it will just reapply this change. So our Azure resource management system is smart enough to not recreate everything from scratch, but will only update the affected cloud resource. But yeah, it's ACD is definitely for you if you're an app developer and you want to deploy entire solutions, as opposed to more fine grain when you use ACC Live, for example, and deploy one thing. But right, I think you've shown the do we have a ability here, Wasim, to show things from Azure Portal, you think?
Yeah, that's actually what I'm already showing here on my screen, which is already shared. And that's also something I wanted to address, because Ravi here in the comments is asking about OpenTelemetry support. So the first thing to know that OpenTelemetry can be implemented with MCP like any other. It's not there's nothing specific to MCP. So you have to, like, capture your spans, your traces, and then send them to your exporter. That's something we didn't do in the main branch, but that's something we are already exploring to add later. However, because we are talking about OpenTelemetry, so observability and monitoring, by default with Azure Container Apps, you can have access actually to the logs. That's the same logs that I showed you earlier, which are running here in my local host when I'm building my app locally. We can have access to the same like real-time streaming logs in the browser in Azure Portal, or you can also, if you're using the VS Code extension for ACI, you can also stream them to VS Code. But yeah, as you can see, what I'm hitting here, my server, because I'm obviously not authenticated, logged in, so I need a token. That's why you have the error. But here on the left side, as you can see, I have all the streams live in my container. So that's like the level 0 of observability. Like, and you want to monitor what's happening in your app. We have like tons of other tools with application insight. And again, to answer the question, when you implement OpenTelemetry with your application in your container, there is included support with container apps. I believe there is like an agent for OpenTelemetry that you can configure, and then it would act as an exporter for your traces, or you can go through the configuration of your application insight to basically read and monitor all the traces and metrics that are sent from your application. And again, we didn't have time to implement this in the support, but we talked with Chris, I think yesterday, about it, and we are exploring like best practices and ways how to implement specifically OpenTelemetry with this MCP sample.
Absolutely. So maybe I can add a few bits on observability, because when you're shipping an app like this, right, it's one thing to ship observability on top of your MCP server. Exactly what you said there, Wasim. You'd use something like App Insights, for example, to register all the things, all the metrics that you want that surrounds your app, who's calling what, when, how long does it take, and so on. All of these lovely metrics, and then you can use Azure Monitor on top of that, so you can build dashboards. You can see exactly what goes on in your app. You can set alarms, whatever you want. But there's another component, because usually when you end up shipping an MCP solution, if you ship a client, if that client has an LLM, that means that's a whole different ballgame. That's a whole set of different headaches. Because if you ship an AI, there's a lot of things that you probably need to ship with it. And we usually talk about using a reverse proxy as a good practice when it comes to deploying anything on Azure. And for that, we can use Azure API management. But for the AI specifically, there's a set of different features that will help you with throttling. It will help you with semantic caching and monitoring and a lot of other things. And you might even use Azure Foundry as an analytics tool to actually analyze what goes on. Everything that App Insights has logged, you can that's pertaining to AI. You can bring that back into Foundry and figure out what input did the user type, what output did that render? Is that good? Do I need to shift my AI operation? Now, I can't remember here in the solution if we're shipping with an LLM, but I'm just mentioning that when it comes to observability, is that yes, you need it definitely for the MCP server, but if you're shipping an AI as well, you should treat that as a different thing that you need to monitor with specific rules around AI. In fact, I got to talk about that on AI Tour. So if you haven't signed up for AI Tour, please do so today. We have an AI tour event, I believe, on the 25th in Chicago. I'm going to be there to talk about this Azure API management, MCP, and how to do observability. So thank you for all the questions on observability, but I'll talk about that definitely. I believe I also wanted to show you some neat tricks that you can do from Azure Portal as we're talking about Azure Portal. So I thought, if you're ready, Wasim, I thought to shift over to my screen and Azure Portal. Right, so here in Azure Portal, I have Azure API management. So I've created an instance in there. So if you've used that before as you deploy to Azure, you know that you have a set of APIs in here. And those APIs can come from many different places, right? You have created them from GraphQL, from a WebSocket, from an HTTP endpoint, or maybe from an Azure AI Foundry deployment. So you see, we have all these guides for bringing in APIs to make sure that Azure API management acts as a reverse proxy on top of that. And the beautiful part here is that we can author a bunch of policies. So if we have a look here, we see that we can set XML policies actually that decides to rules for what should happen to inbound requests. So here we can throttle and, for example, rate limit, as you saw Wasim was showing you earlier. We can do that on the API management instead. Authorization, as we are, for example, leveraging Entra and JOT tokens, we can definitely create an XML policy in here. And we can, if we are, as I said, if we're shipping if you're shipping an AI, we could do semantic caching, but for a normal MCP server, we want to cache some normal tool responses this way. So these are some great things that we want to do anyway as we ship into production. So if you're part of a larger company and you feel like, hey, API management is something we can afford, there's definitely a great environment here and you can add a bunch of policies. One thing I want to show you, because today's topic is MCP servers, is how imagine now that you have put all your API endpoints with API management in front of it as a reverse proxy. There's an easy gotcha way for creating an MCP server with just a few clicks. So what you're doing here is you go into this dialog, MCP servers, you hit create MCP server like this. So you can expose an existing MCP server, or you can expose an API that you have inside of APIM already. So what you're doing here is to select your API. Now I got one of them. And you can start selecting which API operation should actually be part of this. So remember everything that Wasim has built? Well, you know what? You can actually click yourself through this and just say, I want to upload an image, I want to delete a resource, I want to delete a pet, I want to create a user, and so on and so forth. So now we've selected all the operations. We might say that this is pets 2.0 MCP, because we have another one that we created before, and we're just adding something for description. But now within seconds, you have been able to create a, same path. Okay, pets MCP. Let's see here. So this is just because I created an MCP server on the exact same APIs from before. So, but if I hadn't done that, this would have worked. So let me discard this and let me show you the existing MCP server that I have created already. So in this case, we have an MCP server. We can go to configuration and see exactly what we created. And you see exactly what operations I have, like adding a new pet, find the pet by ID, find pets by status, and so on. And we can cancel this. And if we want to test out this MCP server, we can do so. What we need to test it, though, at present state is we need a subscription key. So we're going to use this as a bearer token. So if we wanted to test that, we need to copy one of those two keys. But of course, from a security standpoint, we should probably shut this off and use Entra ID and JOT tokens instead. But for the intents and purposes of this demonstration here today, we'll just show you how it works all the way through. So imagine now I got an MCP server. Imagine I've copied the subscription key, and then I go into my Visual Studio code environment like this. All the way through, you see /MCP like this, and I have a subscription key, and I specify that as part of a header. And now I can just see if this one is awake. So I always do this to say hi to the AI. That's always nice. If it likes me, that's good. And now I can also see, meanwhile it's doing that, I can make sure that my server is up and running. It's actually not up and running. So let's click OK. Let's click start here. Give that a few seconds. You see that thing is starting. And now we should be able to find our server here, pets, and we can see all the operations that we exposed within Azure API management, add a pet, find the pet by ID, and so on and so forth. And if we go into, right, let's see here if we can find the pet. So add a new pet called Mogwai, right? We want more Mogwais. Let's see if it's happy with that. And I'm going to say use a tool also to make sure that it really calls the tool this time. But our server is up and running. It should be able to call the tool and identify what it needs. And it says category ID 1, name creature. And now it figures out exactly how to extrapolate all the things it needs for the tool. I don't need to worry about that. And now hopefully this works and I allow this tool to run. And if everything is good, right, so now it was able to run this tool successfully. So you can see how I started an API management based on an existing API. I created an MCP server, and I was able to bring that back into Visual Studio Code. And I even created a pet in the process, a Mogwai. So let's hope there's no more gremlins in my machine, right? But I'm definitely provoking it a little bit. Let's see here. Yeah, so that's actually what I wanted to show you here today, but I just wanted to show this quickly also because this MCP server is existing, right? And we can add operations on top of this. So we can add policies in here if we give that a few seconds to load, but this is where you then for your MCP server would add throttling, authorization, validation. So you would just go in here and add the policies. So if you've used Azure API management before, you know that there's a set of XML elements that you could be adding here to make sure that your server is resilient, fault tolerant, can be load balanced, and all the other goodness that you get on Azure. So with that said, I think I have one more slide left to go because we wanted to show you all and talk to you all about what's next. So final thoughts on all of this, right? So we have MCP container, the TypeScript repo that we'll be showing you today. Please have a look at it. Please give us suggestions how we could improve things, but hopefully this takes you one step closer to Azure. And also, please try to join the Azure AI Foundry Discord if you are planning on integrating AI as part of your MCP operation. We think you should, especially if you're building a MCP client. A Discord with 27,000 members, so I promise you, you won't be alone in there. Many Microsoft employees are also in there to meet you with all your questions. So please check that out. And yeah, back to the studio.
Thank you, Chris. We got a few questions, and I saw that Wasim just replied to them all in the chat. But if you want to highlight something.
Yeah, sure. Actually, I think Hazel asked a question about how to analyze deployed models. So if you can just switch to my screen, I have Azure AI Foundry opened with a sample demo here. So this is to, this is to answer back to Hazel, Imam, who asked how they can understand and analyze their models. So actually, if you go to AI, if you deploy actually with Azure AI Foundry, you will end up in this portal, which is different from Azure portal. And here at the bottom, you have deployment and quote on other settings. So in your deployments, you will land in this deployment page where you have all your models deployed. And then when you click on a specific model and go to metrics, you will have a lot of stats here actually that helps you, like understands the usage and maybe some of the failures or errors that your model is encountering. So yeah, I hope that answers your question, Hazel. If not, you can probably reach out to us offline, Chris or myself. We have our social links here in the screen, or on LinkedIn maybe. So yeah, I hope that answers your question.
Yeah, so I would definitely say that Azure AI Foundry playground that you saw, it has a lot of tools for helping you understand your models and help you manage your deployments and much more. And as I said, it's a great helper tool when it comes to combining that with Azure Monitor. So as soon as you start using something with AI and you see a lot of incoming requests, you can analyze those and bring those back to Foundry. Let's see, do I have any more questions? Custom transports. I'm not sure that one is in the stars, but I love the fact that you brought it up. So maybe that's something we need to be
That's interesting,
mentioning
actually.
somewhere.
Custom transports are a really interesting topic. I just want to really emphasize that if you folks have other questions, please join the
There's
Discord
also a
channel.
server link here being for the session.
Oh, do we have connection issues? Maybe.
So please go ahead, Wasim.
Yeah, I think we have probably a connection issue. I just want to highlight the Discord channel. We have like tens of thousands of people who can help you answering your questions. That's it.
Yeah, but thank you so much all for coming. Are we back? I think so.
I think we talk too much.
I think Chris broke up a little bit, but we got the meeting. Thank you. Thank you very much for your calls.
Too much
Thanks for
bandwidth.
Thank you.
Thank you, Chris, and thank you, Wasim, for the session today. Thank you all for joining. We're always looking to improve our sessions and your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat, and we'll see you in the next one.